A pleasant day. I am Diana Shell T. Montojo, and I will be discussing the graph of sine function. And in this lesson, we will understand the graph of sine function as well as its characteristics and variations. Let us dive into the basics of graphing sine function. So these are the information that can help us on how to graph effectively. First, let us look at the parent sine function. This is how it looks like. Next, the domain of a sine function is all real numbers, meaning we can substitute any values of x. Next, the range of a sine function is from -1 to +1. And lastly, the period of a sine function is 2 pi. Now that we understand the characteristic, let us now move on in graphing a general sine function. So the general form of a sine function looks like this. And each part changes the graph of the function. The first part is the A, which stands for the amplitude or the height of the wave of the graph. Next is the B. It affects the period because in getting the period, we will have a formula of 2 pi over B. Next is the C. It is the phase shift or the horizontal movement of the graph, whether it moves the graph to the right or to the left, and it is determined by C over B. Lastly, we have the D, which is the vertical shift. It moves the graph to upwards or downwards.
There are crucial steps in graphing a sine function. In step 1, we need to identify the amplitude, the period, the vertical shift, and the phase shift. In step 2, we need to get the midline. The midline depends on the vertical shift, but if there's no vertical shift, then the midline will automatically be y is equals to 0 or the origin of the graph. Now, it's very important to know that the structure of a sine function first is the midline, next is the maximum, next is the midline, then the minimum, and back to the midline. It is the structure of its curve. In step 3, we need to get our 5 key points. And to get the 5 key points is period over 4. And the result of that will be added to our starting point to get the succeeding points. The next step is to find our y value. In finding y value, we will substitute our x-intercept to the equation given for us to find our points. And the last step will be to plot those points in the graph and to connect those to form the sine curve. Now, let's get into the examples.
Now let's graph a sine function with all of those parts combined.
So the A here is 1. Next is the B. The B is 6. Next is the C, which is 5 pi over 3. Next is our D, which is 4.
Now that we have identified the parts of the sine function, we will now go into the step 1 in graphing a sine function, which is determining the amplitude, the period, the phase shift, and the vertical shift. So let's start with the amplitude. To get the amplitude is to get the absolute value of the A, which is 1. The absolute value of 1 is 1. So our amplitude will be 1. Next is our period. To get the period is 2 pi over B, which is we're going to simplify this and it will turn to pi over 3. So our period will be pi over 3. Next is the phase shift. To get the phase shift is we will have C over P. Now our phase shift is 5 pi over 18. So our graph will start at 5 pi over 18. Next is the vertical shift, which is our D. So we have 4. It means that the graph will go up by 4 units. Now we have here the next step in graphing. So we have here getting the 5 key points. And to get those 5 key points, we used period over 4. So pi over 3 over 4. The result of that is pi over 12. So as you've all known, our graph will start at 5 pi over 18. So we will add pi over 12 in 5 pi over 18 to get the second key point. And the result of the second key point is going to be added by pi over 12, then that's our third. And the same steps for the succeeding key points. And that's how we identified our key points. So the next step is finding the y value. So we have here our value of x and then our value of y, which is our sine function. And next is the coordinates of the key points. So we substitute the value of x in the equation that will result to the coordinates of key points and the y value. So here we have 5 pi over 18 is substitute to the equation and it resulted to 4. And our first coordinate is 5 pi over 18 and 4. And these are the next coordinates. And after connecting all of those key points, this is our sine graph.
Good day, I am Janelle Angela S. Bustamante and today I will demonstrate how to graph a cosine function step by step. So we use the general form y is equals to a cosine bx minus c plus d. So first step is we identify the key parts of the function. So the value a is the amplitude, so it tells us how high and low the graph goes. So the value b affects the period. The period is calculated using 2 pi over b. The value c gives the phase shifts. This is found using c over b. And the value d is the vertical shift, and it moves the graph up or down. So for step 2, we determine the amplitude. So the amplitude is the absolute value of a. So this tells us the distance from the midline to the maximum or minimum point. So for step 3, let's find the period. So we use the formula period is equals to 2 pi over b. And this tells us the length of one complete cycle. So for step 4, find the phase shift. So divide c by b, and this tells us how far the graph moves left or right. So for step 5, determine the vertical shift and midline. So the value d moves the graph vertically, so the midline is y is equals to d. So for step 6, plot the 5 key points of cosine. So start at the phase shift. Then mark one full period using 5 points. For step 7, apply amplitude and vertical shift. So move the points up or down according to the amplitude and midline. So last step is step 8. So draw the cosine curve. So connect the points smoothly and forming the cosine wave. Let's graph our cosine function. So our function is equals to y is equals to negative 5 cosine 2x minus pi over 2 minus 3. So the standard period of a cosine is equals to 2 pi. So the first step is we must identify our a, b, c, and d. So our value of a is equals to negative 5. So the value of our b is equals to 2. And the value of our c is equals to pi over 2. And the value of our d is equals to negative 3. So the second step is we must identify the amplitude. So the amplitude is the absolute value of a. So the absolute value of 5 is equals to 5. And the period is equals to period over b. So the period of a standard cosine is equals to 2 pi, and our b is 2. So it is equals to 2 pi over 2, or it is equal to pi. So the phase shift is equals to c over b. So it is equal to pi over 2 all over 2, and it is equal to pi over 4. So our vertical shift is equal to negative 3, and it moves 3 units downward. So now let us identify our x-intercepts. So to find our x-intercept, we must add the period over 4. So our period is equals to pi and all over 4. So our phase shift is pi over 4. So pi over 4 is the start of our period. So our second x-intercept is equals to pi over 4 plus pi over 4, and it is equal to pi over 2. So our third x-intercept is equals to the pi over 2 plus pi over 4, and it is equal to 3 pi over 4. And our fourth x-intercept is equals to 3 pi over 4 plus pi over 4, and it is equal to pi. So our fifth x-intercept is equals to pi plus pi over 4 is equals to 5 pi over 4. So now let's move on to finding our y-intercept. So we all know that the value of our x is this 5. So we put it here, and our function is this. And we must substitute our value of x to our first y-intercept. So our first y-intercept is equals to negative 5 cosine 2 times the value of x, pi over 4, minus pi over 2, minus 3. So it is equal to negative 5 cosine. So the value of this 2 times pi over 4 minus pi over 2 is equal to 0 and minus 3. So it is equal to negative 5, and the value of cosine 0 is 1 and negative 3. So it is equals to negative 8. So that is our first y-intercept. So this is our coordinates. So pi over 4 is our x and negative 8 is our y. Remaining for y-intercept is we will just substitute our x value to our function, and we can now have our coordinates. So this 5 is our coordinates, and we can now plot our graph. So we can see it here. So our first coordinate is pi over 4 and negative 8. And our midline is pi over 2 and negative 3. So our maximum point is 3 pi over 4 and 2. And our midline is pi and negative 3. And our minimum point is 5 pi over 4 and negative 8. So this is our one whole period of a cosine function. And let's identify the domain. So our domain is all real numbers, is negative infinity to infinity. And our range is negative 8 to 2, and it is included. So that is all.
Hello everyone! Now we're going to talk about sum and difference formulas for sine, cosine, and tangent. Now when we say sum and difference formulas, these in trigonometry allows you to calculate the sine, cosine, or tangent of angles that are combinations of special angles. Now when we say special angles, these are those angles that in is belong to the unit circle. For example, the 15 degrees is equivalent to 45 degrees minus 30 degrees. Now here are the formulas for sine, cosine, and tangent. First off, we have sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And for the difference, we have sine alpha minus beta is equivalent to sine alpha cosine beta minus cosine alpha sine beta. For the cosine, we have cosine alpha plus beta equals to cosine alpha cosine beta minus sine alpha sine beta. For the difference, we have cosine alpha minus beta is equivalent to cosine alpha cosine beta plus sine alpha sine beta. For the tangent, we have tangent alpha plus beta is equals to tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. For the difference, we have tangent alpha minus beta equals to tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. Now you're going to use this formula if you're going to calculate some trigonometric functions for an angle that are not part of the standard unit circle, such as the 30 degrees, 45 degrees, 60 degrees, but these can be formed or can be calculated if you add or subtract these known angles. Now take a look at our example here. We have tangent pi over 6 minus 5 pi over 4. Now, looking at the given, we know that we need to use the difference for tangent formula, which is tangent alpha minus beta is equal to tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Now we're going to substitute it with our given. So we will now get tangent pi over 6 minus tangent 5 pi over 4 over 1 plus tangent pi over 6 tangent 5 pi over 4. Now, what do you think is the value of pi over 6 and 5 pi over 4? So if we will look in the unit circle, tangent pi over 6 is equivalent to 1 over square root of 3, and tangent 5 pi over 4 is equivalent to 1. Now we're going to use that here. So we will now get 1 over square root of 3 minus 1 all over 1 plus 1 square root of 3 times 1. Now we're going to multiply it, and we will get square root of 3 minus 1 over square root of 3 all over square root of 3 plus 1 over square root of 3. Now, this seems to be complicated. What we're going to do is that we're going to multiply it with its reciprocal. So, we will now have square root of 3 minus 1 over square root of 3 multiplied by square root of 3 over square root of 3 plus 1. So, you can now easily see the result. So we will now multiply it, and we will get 1 minus square root of 3 over square root of 3 plus 1. Now, for us to get the answer, we need to use the conjugate of the denominator and multiply it to the numerator and the denominator. So we will now get 1 minus square root of 3 times square root of 3 minus 1 and over square root of 3 plus 1 times square root of 3 minus 1. And now, we will now get 2 square root of 3 minus 4 over 2. We can still simplify it. So now, we will have square root of 3 minus 2. So now, the value of tangent pi over 6 minus 5 pi over 4 is equivalent to square root of 3 minus 2.
We all knew that trigonometry half-angle formula or half-angle identities allow us to express trigonometric functions of an angle in terms of trigonometric functions of half that angle. This simplification can be helpful when working with complex trigonometric expressions enabling us to reduce them to simpler forms. The trigonometry half-angle formulas are sine alpha over 2 is equal to plus or minus square root of 1 minus cosine alpha over 2. Next, is cosine alpha over 2 is equal to plus or minus square root of 1 plus cosine alpha over 2. The last one is tangent alpha over 2 is equal to plus or minus square root of 1 minus cosine alpha 1 plus cosine alpha. Each formula plus or minus sign does not indicate that there are two possibilities values for every function. Instead, the plus or minus means that you have to decide the trigonometric function sign either plus or minus depending on the quadrant in which the half angle alpha over 2 lies. So now we're going to have a first problem. So verify sine squared x over 2 minus cosine squared x over 2 is equal to negative cosine x. So we use half angle identities to verify a problem. So first step is recall half angle identities for sine and cosine. So that half angle formulas for sine is sine squared alpha over 2 is equal to 1 minus cosine alpha over 2. And for the cosine formulas is cosine squared alpha over 2 is equal to 1 plus cosine alpha over 2. For our identity, alpha is equal to x, so we'll use these formulas with x over 2 as the half angle. Step 2. Substitute the half angle identities into the left hand side. So we start with the expression we need to simplify. Left hand side is equal to sine squared x over 2 minus cosine squared x over 2. So replace sine squared x over 2 and cosine squared x over 2 with their half angle equivalents. So left hand side is equal to 1 minus cosine x over 2 minus 1 plus cosine x over 2. Step 3. Combine the fractions. Since both terms have the same denominators, so we can combine them to a single fraction. So left hand side is equal to 1 minus cosine x minus 1 plus cosine x over 2. Step 4. Simplify numerator. Expand and combine like terms and the numerators. So 1 minus cosine x minus 1 plus cosine x is equal to 1 minus cosine x minus 1 minus cosine x is equal to negative 2 cosine x. Now, substitute back into the fraction. Left hand side is equal to negative 2 cosine x over 2. Step 5. Simplify the expression. Cancel the common factor of 2 in the numerator and denominator. So left hand side is equal to negative cosine x. Step 6. Compare the right hand side. The right hand side of the original identity is negative cosine x. Since left hand side is equal to right hand side, the identity is verified. That is why we have a final answer. Sine squared x over 2 minus cosine squared x over 2 is equal to negative cosine x. That is why the identity is true for all values of x where the expression are defined.
Good morning, good afternoon, and good evening, everyone. I am Irishi Perez, and today I'm going to discuss about the angle of elevation and depression. An angle formed by a horizontal line and the line of sight to an object that is above the horizontal line is called the angle of elevation. The angle formed by a horizontal line and the line of sight to an object that is below the horizontal line is called the angle of depression. Now, let's have an example. A tourist is using a telescope mounted on a stand 4 feet above the ground. The tourist is 60 feet from a monument. The angle of elevation from the telescope to the top of the monument is 35 degrees. Find the total height of the monument. Before we proceed on the solution, let us illustrate the question first. because in order for us to solve it easily, we have to illustrate or to draw the problem first. So for example, I have a little it is not that nice, but I did my best to try to illustrate the problem, which is like this. It said it says that the telescope that is used by the person is 4 feet above the ground, and the person is 60 feet from the monument, and the angle of elevation is 35 degrees. Now, let us solve the problem. I have here the solution. Let A be the total height of the monument that rises from the telescope. Now, we use the tangent function, which is tangent is equal to opposite over adjacent. Now, tangent 35 degrees is equal to A over 60, which is the opposite is A, the total height, and 60 is the adjacent. Now, in order for us to move the A to the right side and to calculate the value or to calculate the value of A, we have to multiply each sides by 60. Now, 60 times 35 degree is equal to A over 60 times 60. Now, after we multiply, we'll get the value of A is equal to 60 times tangent 35 degree. Now, in order for us to multiply the 60 and tangent 35 degree is we have to solve tangent 35 degree first. So, in this area or in this part, you have to use your scientific calculator. Now, tangent 35 degree is equivalent to 0.7002. Now that we have the value of tangent 35 degree, we have to multiply it by 60. Now, 60 times 0.7002 is equal to 42.01. Now, A is equal to 42.01 feet, which is that was the total height of the monument that rises from the telescope. But since the telescope has stand that has a total height of 4 feet, then we have to solve that since our problem is looking for the total height of the monument from the ground. Now, 42.01 plus 4, which is 4 is the total height of the telescope stand is equal to 46.01 feet. Therefore, the total height of the monument from the ground is 46.01 feet. That's all.